And we're live. Hey everyone, welcome to this week's stream. I'm Daniel Baker, Head of Evangelism, and stepping in for Neil today, who's busy putting the final touches together for our New York meetup. Now, I know that for our UK friends, we're earlier than expected. This is because of daylight savings and honestly an oversight when scheduling the session a few weeks back. We sincerely apologise and hope that it hasn't caused any inconvenience. Anyway, I'm thrilled to be joined today by one of my evangelists, Laura Kerr, who's going to be demonstrating how to use vectors to help with sentiment analysis. Laura, would you like to say hello?
Hi, everyone.
Great. Now, Laura, I'm going to be honest with you. This topic takes me way back to my days of evangelizing AI at Microsoft and using tools such as Logic Apps and the Azure Machine Learning Studio to monitor my social media feeds after presenting at events. So I'm super excited to see how this space has evolved. And I guess for those that may be new to the topic, as a high-level overview, sentiment analysis is routinely used across a number of industries. That could be monitoring customer reviews or investment opportunities. It could be identifying brand value or product forecasting, and really anywhere where you want to improve your products and services and customer relationships. And the data is also readily available and in abundance. So if you have things like feedback forms, social media pages, call logs, and product reviews, and yet not using tools like this, then trust me, I think you're missing a trick. Anyway, I don't want to steal Laura's thunder, so I won't go into too much detail. Instead, let me give you the quick elevator pitch on some of the keywords and phrases that we're going to be using in today's session. So we'll start with vectors and vector embeddings. Now, I know that Neil has gone through this many times in past sessions, but essentially think of these as a mathematical way to numerically represent non-numerical data objects. So again, think things like text, images, audio, and video. Now, vectors and their associated embeddings turn the properties of these objects into a highly condensed format, which then makes things like storage, retrieval, and computation super efficient. For example, we know that images contain millions of pixels, each with a unique color, hue, and contrast. So our embeddings, therefore, can be used to encode the relevant information into a lower dimensional space. Now, to create the embeddings, we push objects through an embedding model, each utilizing specific techniques and algorithms based on the characteristics of the original data. For example, for text-based embeddings, we might use things like TF, IDF, or the term frequency, inverse document frequency. And this is to help us create sparse embeddings by assigning weights to the words based on their frequency of occurrence. We may choose to use things like word2vec, and this helps us create dense vector representations based on the semantic relationships. Or, we could choose to use BERT, or the bidirectional encoder representation from transformers, which I know is a mouthful, but this will help us create our embeddings by predicting masked words in sentences. The upshot is there's so many different types to choose from, and each will have their own strengths and weaknesses. And this, of course, gets much larger when we bring in other data types such as audio, images, and video. But for the sake of our demo today, just remember that the way we create our embeddings affects the way that we store, query, and retrieve them moving forward. So with that, I think that it's time that we jump into the fun stuff and pass across to Laura. But remember, if you have any questions, comments, or observations during the stream, please feel free to pop them into the chat window. Laura, over to you.
Super. Thanks, Dan. So just to follow on from what Dan said there, before we get into the code of the demo, so sentiment analysis really is a way of, it's sometimes called sentiment mining or opinion mining. And it's a natural language processing technique that can be used for extracting and determining the emotional tone or the sentiment in a body of text. We use sentiment analysis to classify text into mainly 3 categories, so positive, negative, or neutral. And some techniques may go a little bit further and have sort of more specific outputs, like strongly positive or slightly negative. But for the purposes today, we're just going to look at the main 3 and categorize them into those 3. So what we're actually going to walk through today is loading our review data. which is going to be our body of text. Then we're going to perform sentiment analysis on the reviews, create vector embeddings, store the vector embeddings in kdb.AI, get the sentiment of similar reviews to a target query. So what this means is we're going to give it a query or a topic and do a similarity search to return reviews that are based on that topic. And then at the end, we'll delete the table as well. So the first thing we're going to do is set up some environment variables and import some packages. So you'll see here that we're importing pandas. We've got transformers, which is for our tokenization. And what the tokenizer does is breaks up the text into smaller chunks to make it available for future processing. We've got tqdm, which is our progress bar and timing library. Matplotlib is going to be used for visualizations. Sentence transformer is what we're going to use for our embedding model. And lastly, we've got our kdb.AI, which we're going to import as kdb.AI from kdb.AI client. And that's for our vector database. So to configure our console here, I've actually extended this a little bit and made it a little bit larger, just so that we can see the review text alongside the sentiments that are returned and the labels that those are given. It'll just be like a little sanity check, just so we can check the entire text against what we've returned. And then we have to find a little helper function, which is just going to return the first 5 reviews from each data frame, just so that we don't have streams and streams of data returned. So for this example today, we're going to use Disneyland reviews, and these are available on Kaggle. And if you don't know what Kaggle is, it's an open source developer community that has things like models and data sets, and it's all free to use. So it's really, really handy for examples like this. Data set that we're using today actually has 42,000 reviews of Disneyland branches. So there's plenty to choose from here. And hopefully there should be plenty of variance in the sentiments expressed. And we're taking them from 3 branches in particular. So that's Paris, California, and Hong Kong. And these are posted by visitors on TripAdvisor. So they're real reviews. So the first thing we're going to do is load in this data. And we're just using the pandas read CSV for this. And then if we take a look at the raw data here, you can actually see there's nearly 43,000 of these reviews. So lots and lots of data to work with here. And we can see here the reviews that we've got. So we've got an ID for them. We've got the review text itself. We've also got a rating, which is going to come into play later on. And this is a star rating out of 5 stars. So this is going to help us later on as we're looking at the sentiments that are returned, just to see that if they match up and if they kind of make sense to what the customer's actual sentiment was. And then, of course, we've got the branch at the end to see where they've come from. So as I said, there's nearly 43,000 results or reviews, here in this sample, in this data set. And we don't really need that for the purposes of the example today. So if we take a look at how many we have per branch, we actually have thousands and thousands per branch. So just to make it a little bit simpler, we're going to take the first 50 per branch just to help with our performance. We can show what we need to show without impacting our performance.
And can I just ask, Laura, sorry to interrupt. So we're obviously doing this on text today, which I guess would be used in 90% of the use cases. But as I mentioned earlier, I'm assuming that we could also derive embeddings from the audio and video feed. So if people have done, blogs of, video blogs and stuff like that, we'd be able to extract the sentiment from there using a transformer and create embeddings from those too, I would imagine, yeah?
Yeah, of course, yeah.
Cool.
Yeah, so if we take the first 50 per branch, if you have access to a GPU, you can, of course, use the entire data set if you wish. You'll probably get different results because you'll be able to have a bigger, fuller data set with probably lots of different sentiments expressed. So we're just going to take the 50 for each. And this is just us grouping by and counting for each of those just to show there's 50 per branch then.
And again, I guess we're just doing that for the sake of clarity. Yeah, I mean, we've got customers that are using petabytes of data, and obviously kdb.AI will scale to that no problem, but it doesn't make it particularly easy when we're trying to demo this on a live session. So
yeah, okay, exactly. And yeah, my laptop certainly doesn't have a GPU. So.
Well, my new one does, but it's
So the next thing to do then is to perform sentiment analysis on these reviews. And the model that we're going to use for this comes from Hugging Face. And again, Hugging Face is another one of these open source developer communities that has lots of data sets and models to pull from. And it's all free to use. So the link is in the notebook if you want to go and have a look. You can, run through this with a different model if you wish, or, there's so much to play with in these libraries. So we're going to import the tokenizer and the model. And you can see here that we're using this Roberta model. And this is actually a fine-tuned version of the BERT model that Dan mentioned in his intro. And what it's doing is going to classify our sentiments into our three labels, so positive, negative, and neutral. We've got our tokenizer, as I mentioned. It's going to break up our data into more, into sort of more condensed chunks so that we can pre-process it a little bit easier. And in this case, or post-process, is going to be our embedding. So what we're preparing it for is the embedding. And then you can see here, we're giving it the labels, we want the three labels, positive, negative, and neutral. So the next thing to do is to configure our pipeline. So our pipeline is just setting up the model and the tokenizer that we're using that we imported just above. And then we're going to create a function that is going to run the sentiments through the pipeline and then assign the label and the score based on the analysis that's been done. So we're also assigning the labels here, as we said above. So the next thing to do is to test this out. So I've just chosen a random review here. So I've just chosen the 10th one, and we're going to run that through our reviews function. Sorry, we're going to pull that out as the example, and then we're going to run it through the sentiment function. And you can see here that this is the review itself. So we've pulled out the text, and then we have that it's been given a positive label and a score of 0.98. So just to kind of clarify, the score is actually related to the label that's been given. So it's not that 0.98 is positive and 0.1 is negative. It's actually that 0.98 is strongly positive, and positive with a 0.1 would mean it's kind of slightly positive, or 0.5 would mean it's kind of middle.
Okay, because in some cases, it's normally 0 would be negative, 5 would be sort of neutral, plus 5 would then be positive. But what you're saying here is each of these labels is weighted between 0 and 1, yeah?
Yes, exactly. So if it was negative 0.98, it would be strongly negative.
Okay.
Yeah. So if we look at the review here, we can kind of see that that is quite sensible. So never ceases to amaze me. That's all very positive sentiments, and so that seems like it's doing the job. So the next thing to do is to run this. Now that we've tested it with one, we can run it for the entire data set. So that's what we're doing in our function here. So we're just adding it to this res variable, and we're using our TQDM progress bar that we imported above. So you can see here it's progressed through, and it gives us the timing as well. What we've done here also is add in some error catching, because the Roberta model obviously has some limitations, as all different models do. And this is why, it's good practice to kind of try lots of different iterations of things to see what's working best for your data set as well. So we can see here that it's broken for 3 IDs, and it could just be that those are too long for the Roberta model to iterate through, which is fine. We're just going to continue with without those 3 for the rest of the demo.
So we're down to 147 inches then, yeah?
Yeah, exactly. So if we add these to the review IDs here, we can see that there's 147 then reviews left. So we've got our review ID, our label, and our score. And if we want to add these back into our main data set, I think this is a good idea to do. So we can see our label, our score, and the review itself. And this is kind of like a little sanity check to copy across and see, are the reviews and the labels kind of matching up? So we can see here that, say for this first one, we've got absolutely fabulous, worth doing, queues move fairly well. So that's a positive score, positive label. There are some more that you can see that maybe aren't necessarily matching up entirely. Like it might not be as positive as you think it would be. but has been given a positive label. And a good way to kind of do a sanity check on those is to match this against the ratings. So while the sentiment analysis model might not be the best for this job, we can test that it's good enough for what we're trying to show today. So how we'll do that is plot the sentiment against...
And sorry to interrupt, Laura. I guess one of the other things to mention as well is the sentiment analysis. If we are looking at the text, it's being looked at the whole body of text, which again is fine for this demonstration, but perhaps in a more productionized environment, we may have refined that transformer model to maybe do it per sentence or via smaller blocks of text. That would then give you a higher capacity to be able to search for sentiment for particular key phrases and stuff, I'm assuming, yeah?
Yeah, absolutely. Yeah, that's exactly right. So if we want to just test it and see that it's good enough for what we want to do today, we can plot it against the ratings that we talked about earlier on. So the 5-star ratings, so out of 5 stars, and see if the kind of general sentiment is correct, the general sort of matching is correct. So if we group these and take the mean of the ratings and then map those against the labels that we've given, if we look at this output, then what we have is, so for negative, we have kind of 3 and below. For example, 1.5 is the average for the negative labels, which seems kind of sensible. That seems about right. And then we can see that the positive ones are the higher marks. So we can also visualize this, which kind of shows it in a nicer way. So the ones that we have labeled positive all have sort of between 4 and 5-star reviews, which kind of makes sense. And then we have the negative ones as well. So they're kind of 3 and below, which again seems quite sensible. So it's good enough. So the next thing to do then with our data is to create our vector embeddings. And for this, we're going to use our sentence transformer. And the embedding model that we're going to use is this mini LM L6V2. And we'll talk about that a little further, a little down when we're kind of defining our schema. So what we're doing here is just using our embedding model to create our vector embeddings and then add them back to our data frame to create this table below. So we've got our branch, label, score, rating, review text, and our embeddings here at the end. And the number of
Laura,
embeddings...
can I just... Sorry, I think you were just about to answer this as I asked the question. How many embeddings has this converted it to?
Yeah, so there's 384 embeddings here.
Right.
And that will all depend on which embedding model you use. So the one we have here is 384. Obviously, everyone's different. So you'll have to judge that by what you're, what you need from your model. So if we scroll down, then the next thing to do is, now that we have our embeddings attached to our metadata in our table, we want to store these in kdb.AI. So to do that, we need to connect to our kdb.AI session. So when you sign up to kdb.AI, you'll be given an endpoint and an API key. And if you're on this line here, you'll see you'll be given your endpoint and or you'll be prompted for your endpoint and your API key, and you can pop them in there. And then just using kdb.AI.session, you can connect to your session. Once you're connected, then the next step is to create your schema for your table. So the first thing here is the kind of metadata columns that I talked about. So we have branch as a string, label, score as a float, rating as an integer, and review text. And then this is kind of the new part at the bottom here. So this is your embeddings, and this is where we want to give some information about the embeddings that we've created and what kind of index we're going to use for our search. So as we mentioned above, with that model, we've created 384 embeddings for our data. So this is where you input that to tell the database what to expect. And then you're also saying about what index you're going to use for your search. So here we're using HNSW, and we've used that a couple of times in previous LinkedIn Lives if you've attended any of those. And we've had a little bit more information about it as well. So I'll just give you kind of higher up view of it. So HNSW is hierarchical navigable small worlds, which is a nearest neighbor search using a graph index. And we actually have a lot of information on our Learning Hub. If you scroll down, you can get samples, there's demos, and there's also the fundamentals. So if you want to go to like our indexing basics, you'll find out a little bit more about the types of indexes you can use, and a little bit more information about how they work. So once we've created our schema, then the next thing to do is to create the table from that schema. So the first thing we do here is just check if the table exists in memory and drop it if it does, because we want to create a new table. So we use session.createTable to create our table from the schema, and then we insert our embedded data into that kdb.AI table. It'll return true, and then we just want to double check that and just kind of verify it. We can use table.query to do so, and you'll see that we've got our 147 results, and this table is returned that looks exactly the same as the one we just created. We've got all of the columns that we were expecting, including our embeddings, but the only difference is this is now coming from our kdb.AI vector database as opposed to from just in memory here. So now the next thing to do is to do our similarity search. So we've created a little function here to take the given query, embed that as well in the same using the same embedding model, perform the search, and then return the results to us. And you'll see here that we have an input. You can input how many results you want returned as well. So let's see that in practice then. So the first query we're going to use is, are customers satisfied with the food at the park? And we've asked for 25 results here. And then if we just show that, you can see we've got our 25 results here. And we can see that we've got our label and we've got the review text, so we can kind of see what the general sentiment has been around the food. So you can see for this first one, strongly negative, and you can see that clearly from the review text: pre-made, sad, deep fried, unhealthy fast food. So not a great review. And then we've got a little, some more here as well, and some that are maybe seem like they're maybe not as positive as we would have thought. So this has got a positive review, and it's related to food, but the review itself overall is kind of positive. So there's obviously a little bit of critical thinking need in these cases, where you can kind of analyze it a little bit further once the results are back as well.
And I'm guessing, just sorry to interrupt, I'm guessing that really breaks down to two things, right? I mean, first, we've only got 147 reviews, so I'd imagine you'd get some erroneous entries in there as it pulls back the nearest neighbours. If there's not enough entries for food, then it's going to pull back the nearest neighbour, which may be unrelated. And I guess the second thing just goes back to the point that I made earlier. We've used a transformer to create the sentiment for the whole body of text. In a more productionized environment, we'd probably split that up into smaller chunks, right? And then you'd get better search capability from it.
Yeah, exactly. Yeah, and you can see the nearest neighbor distance as well here. So that it's important to look at as a whole. So another way to kind of look at these results then would be to group them by branch. And the way to do that here is we're just grouping by branch and doing a count of the sentiments for each branch. So we had 25 results, and we can see here that of those results, it's pulled back the most regarding food for Disneyland, and the fewest for California. So it can be split up like that. It's not going to pull it all from one, or it's not going to pull it all equally. If there's more results from Paris, that's the way it will fall then.
Okay, so what you're saying is it's weighted more negative for the food towards Paris, but overall there's more reviews for Paris anyway, so it kind of balances. Okay,
exactly. Yeah, so we can see that a little bit more clearly just down below, because we're going to visualize these results as well. So if we use our matplotlib library that we imported above and use the same query, so are customers satisfied with food at the park, we're pulling back 50 results this time, and we'll see if that makes a difference to what we've got here. So yeah, you can see mostly positive results, but again, Paris has the most reviews in general that have been pulled back regarding food. So it actually means that Paris has the most negative results as well. And again, whatever the way the data falls. If you use a bigger data set, that could be a completely different results returned. But these are the sentiments for the ones that we have pulled back. So if we automate all of this and put everything we've done basically into one function, so we just give it a query and we want the whole thing visualized for us. You can try this again with another query. So what do guests think of the rides and attractions? We've asked for 50 results here, and overwhelmingly positive here the results are, which is good because that's kind of what you expect for Disneyland. We have positive results all around, apart from just a couple for Hong Kong that have fallen into the negative and the neutral. And then one last one, if we ask the same sort of question, so what do guests think of the staff? And again, we'll pull back 50 results. We can see here that mostly positive, a bit more of a split this time. But again, Paris actually has the most reviews that have involved the staff. So they've ended up with the most negative reviews involved with staff as well. So that's just the way that the data has fallen. And of course, we've mentioned this a few times now, but the more reviews you use in this case, the more data you have, the more meaningful insights you'll have. So anybody who has a super duper machine with a GPU is going to get a lot more meaningful results if they're able to use the whole 42,000 reviews to get a good insight on the full data set. And that's the end of the sample. The last thing to do really is it's good practice to drop your table once you've finished with it, and you can free it up for continuing to do the rest of the samples or join in with another LinkedIn Live. But yeah, that's it for me. So thanks for listening.
Awesome. Thank you very much, Laura. And again, great demo. And I appreciate that you're feeling a little under the weather today. So I appreciate you taking the time and soldiering on through it. Now, no questions from our viewers, which could mean one or two things. Either A, we've absolutely nailed this, or B, I've done something wrong with the stream. We're just talking to ourselves. But I'm hoping it's A. For our viewers, if you are there, I hope that this session has highlighted some of the use cases that we're seeing with kdb.AI and has inspired you to check it out. To do so, head over to kdb.AI and sign up for your free cloud edition. It's super simple. It doesn't require a credit card. And when used with the samples over on the kdb.AI Learning Hub, as Laura showed earlier, it will have you up to speed with vector embeddings and their use cases in no time. Now, of course, if you do have questions, then you can reach out to us on our official Slack channel or contact either myself or my team through social media. We're always happy to hear from you, or better still, come and meet us in person at one of our many Vectorize events. Simply head over to the KX website and see when we'll be in town. We would love to see you there. Finally, I would once again like to extend my thanks to the awesome team of people at KX who really make these sessions possible. This includes our pre-sales teams, engineering, R&D, and of course, evangelism. Now, normal services resume next week and Neil will be back at the helm. So tune in to see him talking with Michaela Woods, who I believe is going to be working through RAG approaches. So with that, I thank you all for your time and look forward to connecting with you soon. Laura, thanks again for your time today.
Thanks, Dan.